Well, welcome and bienvenue to another weekly hack night to NeurotechX. So, NeurotechX is an international community that facilitates the advancement of neurotechnology. Our pillars are community, education, and innovation. We have chapters worldwide, meetup events, although everything's kind of paused for COVID, and a very active online community. I need to change that. It's 4,500 now members on Slack. If there's not a chapter in your area, please get in touch with us. We love to help you set one up. Or if you're in a university, start a student club. If you aren't already on Slack, I can give you the bit.ly access, and you can check out our online resources and newsletter. So thanks so much. And yeah, we are just getting started. But this is the usual time that anybody here for first time just asked if you could introduce yourself and say a little bit about why you're here.
Okay, I can start.
Sure, Nadim, yeah.
So I'm last year PhD bioengineering student at University of Pittsburgh. I'm currently writing my thesis. Mostly I deal with neuroimaging and also work with some ultrasound for the brain, where we can try to estimate the pulsatility in depression. And yeah, that's basically.
That's awesome. Yeah. So and yeah, I've talked with Nadim before, and we've exchanged references, and yeah, pretty excited at some point to see if we can get him to come back and talk about ultrasound. Yeah, would you also like to just introduce yourself briefly?
Sure. Hi, I'm Julia. I run a small neurotech startup called MindX in DC. I also have, we have one person over in San Francisco. He isn't joining tonight, but I've been, lurking on the NeurotechX Slack channel for a long time now, and figured I might as well join one of these at some point. Yeah, so software engineer background originally, but we're building a small non-invasive imaging system with I could get into that at some other point, as well as software for making it useful for mobile computing. So yeah.
I'm very happy to let you talk more about that later at length.
Sure.
Okay. Yeah. So it's mainly just to tell people that we're not on schedule, in the sense that our speaker for today is asked to speak at 7:30. So we will be just talking about. Can somebody mute? Hello? Okay. So yeah, we will, well, I guess we can start with the news from Kernel and the news from Neuralink. So, Neuralink's at least set a date to tell us more. I don't know, who gets invited to those things, but more important people than me. And but I look forward to seeing it streaming. And yeah, it's I don't know. I don't have any insider info, but then of course the other news is that Kernel got 53 million outside funding, which is interesting, and apparently for the same neuroscience as a service, but as a service to businesses. Mm-hmm. Which I guess is a little bit like some of the services that basically work for drug companies in terms of running, doing animal research and, testing things and trying out basically contract research labs. That's my assumption, but I guess it would be on humans, or at least all the devices that they showed off in their last release seemed like human neuroimaging systems of both optically pumped magnetometers and I guess they were, was it time domain years? I forget. Yeah, time domain years. And yeah, so I don't really have much to say about it. If anybody else, I'm it's nice to see that they got VC interested, I guess.
He's very accessible.
Yeah, I think it's pretty easy to invest in in something that's already had like 100 million down. And who are we getting the? Okay. Yeah. So that not really earth-shattering news, really, but I'm still waiting to hear back in terms of what their service is, if they're making that any more generally available. But I guess it kind of makes sense to just focus on businesses, and like this is not going to be something that we'll be able to get access to.
I think they mentioned some neuromarketing kind of stuff too, until they can have something that's miniaturizable enough and at a consumer price point. You either go medical, or you go neuromarketing.
Yeah,
neuro as a service, I suppose.
Yeah,
the business model.
They seem to be like you're saying, like neuromarketing and or potentially testing other things. Like I know that he's stated previously that his real interest is in health and somehow improving especially mental health care and treatment. So I don't know if it would be related to something like Amit Atkins' Alto Neuroscience, where they're like using EEG to predict treatment response, antidepressant treatment response or something like that. But they've got the best equipment that money can buy, so to speak, right? Yeah. So any other thoughts on that? Yeah. Yeah. But there was a lot of other things going on in terms of the two big conferences going on right now. Was medical imaging, deep learning up in Montreal, and that definitely was a bit more of a neuro focus. Did you catch any of those, Nadim?
I was attending that conference in Carnegie Mellon, so I had to choose either that or the middle.
Okay.
But I reviewed the program in the middle, and it seems to me it's becoming more technique than focusing on the data.
Oh yeah, it struck me as definitely more like a MICI.
Yes, exactly.
Yeah, and yeah, I kind of wondered about it in terms of like, it seems like a direct competitor to MICI. So let me, so I can put this in the, for people not familiar with these particular.
And the very interesting thing, it's getting the middle, the deep learning imaging is getting attraction of vendors like NVIDIA and Philips. And so they're giving more sponsors than MICI. I don't know if it will get attraction in the future.
So, and you know, this definitely had, yeah, I mean, it had some, you know, I mean, certainly Daphne Kohler, I loved her talk just a couple weeks ago, because what were they doing? It was like computational biology and machine learning, I think was, yeah. And anyway, Alan Evans, for those who don't know, very, very senior person in neuroimaging world. So I think wasn't the first, maybe the first HBM was in Montreal. Anyway, I know he did something. He did a nice overview of neuroimaging as his keynote, and that was, yeah. So the definitely a lot of NVIDIA doing posters and like rolling out products at this particular conference. But I think they'll be at MICI too, you know. Anyway, these are more neuroimaging, and yeah. So the other conference, or the summer school that's going on right now, is the Krembil Center for Neuroinformatics, which is doing this 5-day. Sorry, I should have these links ready. So and even better, because this is the lessons that that we're going through, and you know, it's we just finished day 4, so it's kind of over. But this is 5 days of multi-scale modeling of depression, and it's starting with genetic analysis, then cellular physiology, and basically what they're calling functional genomics. Day 3 was whole brain modeling. I mean, well, circuit modeling, cortical column kind of specific modeling, and then whole brain modeling. And then today we covered reinforcement learning plus dynamic causal modeling of EEG, so model-based EEG analysis. And tomorrow will be this, I believe it's population epidemiology. I think we're going to be back to psychiatric epidemiology and population-based subtyping. Cool. So for those aren't familiar with Amit Etkin's Alto Neuroscience company, this is a paper from February, I believe, and demonstrating that you could use EEG to predict basically treatment response to a particular neurotransmitter, right? So it wasn't saying that they could find a neurotransmitter that would work. They could just assess whether you would respond positively or negatively to a particular neurotransmitter. And that would be like an ideal, if you could imagine this summer school is set up to try and find those kinds of applications, so let me just find that particular. And Atkins Lab's also done a lot of great papers on, TMS, effectiveness, and so I'm scrolling past, things like global connectivity and local excitability changes underlie antidepressant effects of our TMS. Yeah, here it is. So here's the one. Oh, hey, look! I didn't realize Cami rolls on that. Maybe we can get Cami to come talk about this paper. So that's awesome. This is for an EEG study. 309 patients is pretty good, or 309 subjects is pretty good, and they're just using machine learning of the resting EEG to make this prediction. Now, yeah. And there is a comparison with the with our TMS, and of course this is not exactly the same group, but this is also where the SAINT studies is happening, which is looking at theta burst RTMS. Theta burst TMS, and its comparable effectiveness to ECT, which as was covered in Kremble, at the Kremble Summer School, is still considered, the most effective treatment for what's referred to as treatment-resistant depression. So that's where you've used multiple antidepressants, basically trial and error, and not seen any improvement, right? And so obviously they'd like to find a way that it didn't have to induce seizures to provide a treatment. And yeah, so
I can personally vouch for its effectiveness.
Yeah, it's great, a great summer school. I don't know if, about a month ago, we talked about Bradley Wojtek's most recent paper in bioRxiv, and the summer school was this summer school covers that kind of range in terms of our RNA-seq data, cell type prevalence, and across the cortex from Allen Institute's brain map and cell map data sets, and then linking that in to simulations so that you can actually load cell types from Allen Institute databases into Neuron, which is a terrific C++ package for computational neuroscience, and so this is all in LFPy, and then covering John Griffith's work, who's probably resting after 4 days of doing this summer school, teaching the summer school, and who covered basically the virtual brain project. So that's the work of Victor Ursa, Randy McIntosh, and Petra at Charité. I'm blanking on Petra's name. But Virtual Brain Project, TVB, and yeah, and then going into today, where there was some talk about behavior, modeling behavior and predictive coding and things like that, hierarchical Gaussian filters. But you kind of need to cover that to then get into dynamic causal modeling of EEG plus, or EEG MEG plus behavior. And then that was when we got into processing mismatch negativity data, and using, for those who aren't familiar with SPM, the EEG example data that is available with SPM. And let me just put a link. Well, again, off of the Kremble Summer School, they've got links for all of this. But that is the standard. It's a 128 biosemi system data set using a roving mismatch negativity paradigm. So for those who aren't here every week, we talked about UC Davis and the Luck Labs ERP core data set, and open resource in the sense that they're making 40 subjects of ERP data available in 6 kind of canonical ERP paradigms, and one of those is of course mismatch negativity, right? And so we were talking about, like, okay, how exactly is mismatch negativity different than P300? And the good, again, I've picked up something at this summer school because I can answer that question better. So mismatch negativity is more defined as a difference wave. I mean, ERP studies in general are going to be, you're going to be looking at difference waves, but the mismatch negativity is defined as a difference wave, and it is like we said last week, it's a passive paradigm where you're kind of doing another task, right? And you're presenting tones of a different frequency, 20% some tone and 80% the other, and unconsciously, your auditory cortex is and some other areas are processing that and will recognize that novelty, but it is defined. It's a much earlier portion of the significant difference wave between the frequent and rare. Okay, and whereas the P300 is this cognitive oddball where you are either counting the rares or you're pressing a button when you see the rare, and that's that later 300 millisecond or P3 component. Anyway, I wanted I felt like it was good to mention that, since we kind of hedged about it last week in terms of what exactly is that. Now, as I understand it, the roving, so again, like, why is it cool that somebody's giving us 40 subjects of data collected all these canonical ways? It's perfect for us in terms of testing new systems, right? So, certainly one of the things that I wanted to talk about with Josh, who's joined us, is this free EEG 32 board that they're going to be doing crowd supply, funding round for in, well, hopefully a couple of weeks, but maybe some delays because of parts, Josh.
Depends.
Yeah.
We don't need to delay the crowd supply,
okay.
Just because of the test boards that we're waiting on, because we know they work.
Okay, gotcha.
On if crowd supply wants to play or not.
So that crowd supply will be next week.
Well, tentatively it's starting on the 16th. Yeah, so a week from now. They haven't. There's a bunch of stuff they haven't given us yet to fill out though, so I'm not sure if that'll actually happen. With all
So
this prep that we have to do.
I just dropped in the crowd supply link, and you know, I think one of the you know, great things that you can do now. You can do this. You could potentially do this with some other tasks, but you know, the Luck Lab is particularly special as the, you know, ERP lab of for many people of reference, and yeah, and we've got their, you know, so they, as part of that open resource, they make their presentation scripts available, so we can literally run the same experimental control software that they used to collect the data, and you know, because we've got access to the hardware, we can add the kind of the trigger, you know, trigger control that would be necessary to pull out that. And yeah, it'd be a really nice way to kind of validate the yeah, the noise levels of the system. And you know, I think using using this with, you know, like a research cap like Davis used would actually be a great way to, you know, yeah, just show people that you can collect exactly the same herps with this, and then we can move to non-standard electrodes, right? So yeah. Anyway, the mismatch negativity in ERP core, I believe, is not a roving paradigm, and the difference is that is basically during the session you switch the rare and the frequent tones, so that the rare tone becomes the frequent tone and the frequent tone becomes the rare tone, so that you can then basically average out or remove the effects of the stimulus itself. So because both tones will be at some point rare and or frequent, you know, rare and frequent, they can, you know, you can say that the waveform doesn't have anything to do with the stimulus itself. It's just about the, you know, its frequency. Does that make sense? So I think that's the only like special thing about the what's called the roving MMN that is the example data set that comes with SPM. And so for those who aren't in the imaging world, SPM is like one of the most widely used neuroimaging analysis packages for fMRI. It actually started as PET imaging, and then fMRI, and you know, together with CAT12 gets used for anatomical stuff too. But is still the only package where you can do dynamic causal modeling. And you know, I always like to point out that like that's still a very unique, you know, there aren't any other model-based, or other than things that people have written for themselves for particular analysis studies, there's no other model-based EEG package. And so DCM is a really unique electrophysiological analysis pipeline, and yeah, can't emphasize that enough. So, and because again, what you're doing with that is embedding a Janssen-Ritt 1995 computational model of, you know, cellular, you know, cell populations of the cortical column into your analysis stream of EEG, so that not only are you talking about kind of connectivity between brain areas, but you can, you know, even use it kind of more physiologically to get at which parameters are distinguishing particular groups. So in the studies that they did with mismatch negativity, they actually did a psychiatric study of schizophrenic patients and healthy controls. And so they could end up using the parameter fits across subjects and then grouping them by condition, and then looking at like, well, how do these parameters differ, assuming the same network topology. Again, the links are there, and yeah, really, one of the things that John and I have always hoped to do is to make a Python version, or make a version available from Python, and yeah, so that is
of SPM, a Python SPM.
No, specifically of DCM.
DCM, okay.
So it's there in Neuron, right? Like there's a Janssen-Ritt model is quite an old, it's an old comp neuro model, and so for those who aren't familiar with there's another tool called human neocortical. Is it human neocortical solver? Let me just show you this in terms of its. So this particular, they're already kind of doing it. Stephanie Jones has always been, her research has always focused on how to use computational neuroscience models to understand EEG, MEG, right? And but they've finally, okay, NeuroSolver. I was trying to figure out how to get the last N there. Sorry. So here's a pipeline that kind of does that. It's what's special about SPM is SPM uses says I'm not going to kind of change my underlying cortical column model for every analysis I do. I'm just going to use this Janssen-Ritt model and 3 cell types, and that's it, right? What Stephanie's got here, hey, there you go.
Hey.
I'm trying to talk about human neocortical neurosolver.
Oh, cool. Yeah, I know it well. What about it?
Did Stephanie Jones talk at the Comp Neuro meeting that you did a couple weeks ago?
She didn't, but I've seen her talk a bunch of times. We're having her for a seminar in a few months as well.
Cool. Okay.
Okay. So I'm kind of somewhat up to date with that stuff, I think.
So did you join us because I said John and I have wanted to produce a Python version of DCM?
Who's joined us?
I was saying that we've always wanted there to be a Python version of DCM.
Yeah. Yeah, I started unpacking that beast a few years ago, and it's very informative exercise, but putting it back together again is, there's a lot of stuff in that toolbox.
Well, anyway, thanks for joining us. I know it's been a super busy week for you. I thought I was just talking about is it Andrea
Dakinescu.
Okay. Yeah. So talking about her modeling, like it was nice to get that. I mean, those are some extra scripts, right?
Yeah, the code's there.
Yeah, no. I mean, but it's like those are some extra script. Like that's not just how it is normally run out of the box.
The HGF stuff.
No, the mismatch negativity.
Right. Yeah, I think the analyses they did was pretty closely following from the stuff that's in the SPM manual and tutorial, which is the mismatch negativity DCM thing. So I don't know. I don't know if there's like lots of extra stuff on top of that, but I mean, the thing that they did differently is the way they kind of treated the conditions in the experiment. But in terms of like running the analysis, it's probably pretty similar to the code from. You can dig it up. It's in the. I'll tell you what, I'll put a link in the chat. I know where to find things in SPM. It's kind of a labyrinth.
But
I've spent enough time there.
I wasn't sure, I mean, looking at her background, I wasn't sure how much of that was, kind of like Zurich's take on DCM, versus like kind of vanilla SPM.
Yeah, that's exactly right. That's so there's this toolbox called Tapas.
Yeah.
Which is basically a bunch of add-ons to SPM and DCM from Klaas, Stefan, and co.
Yeah.
And I don't really know much about it, but yeah, that's the Zurich take on things is based around Tapas.
Yeah, which is awesome, right? I mean, another that's added value on an already awesome pipeline, and there's a lot to unpack from this week, and anyway, just talking about human neocortical neurosolver as being, in some ways, like what Stephanie's got is that, non-SPM pipeline, in that like she's trying to embed neuron, with free surfer imaging for setting up your problem, and neuron as your much more advanced Janssen Rit.
Yeah, that's right. So there's, I mean, a few things to say about that. So what they do is they use pretty kind of pared down neuron models.
Yeah.
So they're compartmental models. So they have like the dendrites and the axon and all of that spatial stuff, but they have only about 4 compartments in the dendrites and in the pyramidal and in the it's called the axon that spans the layers. So they're quite kind of minimal as far as multi-compartment neuron models go, and that's something that it helps a lot with running things quickly if you only have like 3 or 4 compartments in each neuron. And I spoke to her, so I was asking about this. I saw her in Paris in January, and I was asking about MNE and kind of spatial source stuff, because this was my impression was that was, that they were taking neuron and inserting it into MNE source, toolkit, and then using the MNE cortical surface free surfer forward models, right? And that's I think the kind of state of play on that is that's the plan, but they haven't actually done that yet.
Okay.
As in really kind of building in the geometry of the cortical surface with the forward models. At least they hadn't really. They have forward models, but they hadn't really been kind of doing anything particularly complex in terms of like spatially structured sources. Which I kind of thought initially that was the whole point, but that's still on the roadmap for the future, I think.
Well, one, I noticed that they are hiring. So they are looking for that person to do that. And it seems pretty clear from the job description that that person would be implementing exactly what you just said. Yeah. But yeah, it'd be very interesting to hear. Do you guys record your I mean, are you gonna do, is this like a seminar talk?
Yeah, I think it might be public. We're doing this Zoom-based virtual seminar series, and I'm not exactly sure. I think they're being like tweeted and with the Zoom info and everything.
Okay.
So this is new, but I think the next one is Gauti Einavol, who also works on this kind of thing. Yeah. So the Stephanie Jones one might be, but she also, I mean, there's a bunch. She does like loads of talks. She's kind of quite a popular person to.
Yeah.
So if you just like look up, Google her, you'll find a bunch of videos online, pretty up to date.
And like you said, like the without detracting from her work at all, like the software kind of lags behind what they want to do. And so yeah, you can catch a lot of her YouTube and really learn about what the current software is doing.
Yeah, they were in the middle of because they realized, I guess, like over the course of developing it, there's this other library called NetPine, which kind of got developed in parallel and does a much better job of abstracting the models at the level that they want to be able to do it. Yeah. So I think basically they're in the process of just completely rewriting the back end for the Neurosolver to use NetPine.
Yeah.
And keeping the front end kind of similar. But the front end is just a somewhat okay GUI at the moment. There isn't an API.
Yeah. Yeah, it's not code I would want to try and emulate, but I know that NetPine GUI is being developed by Metacell, and certainly for the kinds of models that you want, what you want to do is be able to generate a whole bunch of neuron models. In parallel. And anyway, that was some of what I caught at Barcelona last year at CNS, which is a good segue into next week. Or wait, will it be? Is it 2 weeks? So is it 16th through the 18th? I forget. So CNS, Computational Neuroscience Society, is meeting, or neuroscience is meeting 16th, 18th. And that is free to register. Sorry, I'm dropping that in. But check it out. And oh yeah, open source brain. Yeah. This was so Ankur Sinha, who leads NeuroFedora, has been really good at keeping us up on all the computational neurosciences packages, and I think he was a part of Open Source Brain conference, which was like, I want to say last year.
Recently, they had a workshop recently, the paper came out recently as well.
Okay. Yeah. I mean, like he was definitely a part of that, but it's been, yeah.
Did that sell you Open Worm or Open Fly or something as well?
Well, so OpenWorm, or I always think of Bradley Alicia as OpenWorm person. So this is, you know, a C. elegans, like a full model of C. elegans, and yeah, he's you know, he's done a bunch of really great projects, and I know as a mentor, well, you're doing a Google Summer Codes mentorship, right?
Yes,
Yeah.
I have 2 Google Summer Code students. Yeah, they're doing neuroinformatics stuff with
TVB?
no, well, yeah, with TVB a bit, but with this tool called Neuron Unit, called Psi Unit, which was I'm co-supervising with a chap named Rick Gherkin, who's a prof at Arizona State, and so I mean it's a bit of a sidetrack. I don't want to, but Psi Unit is kind of is this it's trying to take the concept of unit testing from software engineering
Okay.
and do it in a context of science, and particularly in the context of science where you have models, because there's a lot, I mean, there's a bit of an issue that is somewhat recognized by a very small fraction of people who do computational science, that we don't write tests to kind of confirm that stuff works like enough, and there's a kind of level at which it makes sense to have use some of the principles of unit testing in the way you develop computational models. So that's what the students I'm supervising for.
That's cool.
That.
That's cool.
I think it's the Flute Fluoride Brain Observatory is the other meta cell thing that I was thinking of.
I see. I mean, so Psi Dash is he's involved with Psi Dash?
Yeah. Well, I think Psi Dash is the umbrella thing around Psi Unit, if I'm right.
It looks awesome.
Psi Unit.
Oh, okay.
Yeah.
Okay.
But we're doing Psi Unit with TVB. Actually, Psi Unit with TVB and Psi Unit with FOOF.
Oh, Fruit Fly. Okay. I'm not familiar with that one.
Yeah,
But
as in Wojtek FOOF.
right. Wow, that looks cool. Anyway, OCNS is coming up. And I forget, I think like Botvinnik is doing a keynote, and a couple other people. Let me just scroll down here. Okay, 18th to the 22nd. So yeah, it's more kind of like 2 weeks from now. Sorry. Starting next week is NeurotechX Academy, and which, you know, sounds like it is going to be epic. And you know, I believe I think the Python like pre-workshop or pre-course has already started. So, and I'm seeing a lot of you know, people raving about it on Twitter. And anyway, I mean, I certainly loved everything that they've done so far, and that should be, you know, they're making everything available. So, you know, it's I mean, Nadim asked about it earlier, and you know, you can be an observer in the sense of like, you'll have all the materials that the kind of like the students that applied and were accepted, and will be working with TAs, you know, interactively. But it will be a full-time course for, I think, almost 3 weeks. I think it's
Yeah, too.
And is everyone here doing it?
No, I didn't hear about it in time, but I'm gonna follow along with the material and just like, I know Abby's doing it and someone else that I've talked to on Twitter is doing it, so I'm gonna see if I can get links from them and stuff and like work through it when I have time to.
Good. Interested to hear how it goes.
Yeah. So I don't know if you remember from BCI 101, but Jao, with like Brazilian name Jao, like Joao. So he's a student at Cambridge working on like EG analysis of learning. I mean, reading difficulties. Anyway, he was accepted as a student. So
in Cambridge, do you know?
Yeah.
I know who with. Used to
I
hang around
will
with language people in Cambridge.
I will let you know. Anyway, since we of course try and keep on track on time. Oh yeah, here's. So I know he said on Twitter he was said on Twitter that he was he'd been accepted, and yeah, so I'm going to catch, I certainly hoping that he'll talk about his experience, and love to hear that. He was a good part of the BCI 101 socials back when those were happening. So usually at 7 o'clock, we had to switch things around a bit, John, because Issy asked to speak at 7:30 instead of 6:30. So now would be a good time to check in on EEG notebooks and see if we want to try and track any of the, I mean, I know what Jaden's hitting is exactly what Simon and Andre Shmakov, not Parfenov, but hit with Linux, just in terms of like, basically, well, I don't know if Simon's got his mic and wants to chime in on this, but it was basically like, you've got to comment stuff out to get anything, and even then it seemed like there was still a remaining permissions issue. So yeah.
Yeah, I was just getting a variety of issues on Linux in terms of trying to get the BLD dongle to work. So yeah, if anyone has like successfully gotten it running on Linux and would be able to provide some advice on that, that would be great.
So you don't have any other options right now? I mean, there's no way you can put Windows on a.
Oh, I have a Windows drive. I just wanted to do this for the sake of.
I mean, this was what Blueberry very kindly spent some time on.
Yeah.
And so they've got that particular. Let me just for those who aren't familiar, we're talking about this particular NeurotechX EEG notebooks project, and
I'll share the link to our branch as well.
So then this is just about the basically the Linux specific issues that we're having. So I think it's good if or certainly again what yeah.
Yeah, I should probably merge this pull request. I can't test it because I don't have a Linux machine.
Well, so
it's always like the case with these things.
So can you test it on Windows?
Well,
yeah, but I can't test the Linux.
It's fixing this particular problem, and like I said, like we know that this is it's definitely related to the Mac changes. That if you go through the Mac instructions, then you get to this one step where it's just like, and now now comment out this stuff, and inside the installed Python package, and yeah, you know what I'm talking about, right, John?
Amanda's things, you mean? Amanda fixes, yeah.
And I'm pretty. I think it's somewhat related, but I think that there's also kind of like a certain permissions problem with this particular tool that this code is using. And yes, Simon. Yeah. So Simon doesn't have his mic and is right.
So it doesn't use HCI. That's okay.
That if I remember right, let me. Okay, I should be able to test this though, John. Or if we're talking about just the using the Muse hardware.
That would be great, Simon, if you could take a look at it and see.
Yeah. So hopefully he'll be right back.
Because when I run the HCI tool, it doesn't even read my Blue Giga dongle.
And it if you're able to.
Let me write all this down because I'll document all this as well.
Yeah, and I've got so I know I was hoping Andre would be able to join us too, but he had a conference call with people in Japan, and it's like early. It's their morning now, so it might go late. Let me. So give me 1 second. Because I've definitely got some of this documented under what we were calling PyGap problems.
Yeah, what kind of problems are you getting then? In a nutshell.
Me?
Yeah, you Jaden.
So right now what I'm getting is whenever I run it, this is just running use LSL, I get this strange thing that tells me the adapter, the BLE adapter needs to be reset after the privileges were, after like root privileges were given. And so it tells me to run like in PyGat, I think it is, or maybe it's in PyLSL, the adapter.reset call. And every time I run it, it just doesn't work.
Oh, okay. Never seen that. Yeah, sorry.
Here,
so if
I can't share my image because Firefox won't let me for some reason.
Here,
Of course. Linux.
Yes. No.
I don't. So when I run an HCI tool, I don't see the adapter at all, and I don't know if it has anything to. I don't think it has anything to do with the fact that my motherboard also has a BLE adapter because I have two other Bluetooth adapters that when I plug in there, they show up in the HCI tool, but the BLE D1112 does not.
Right. And anyway, I dropped in some stuff from Simon a while back, and this is what this is how he was managing to get a successful streaming session.
Okay.
Yeah. Well, thank the Googles for this is the benefit of having message history as opposed to our free version of Slack. Just saying, this is from March 24th, and this would be down the memory hole if we'd put this on Slack. Anyway. you know, but I'm going to try the same thing here. So for those of you who aren't in the weeds of EEG notebooks, just wanted to say that we've also but if you are interested in getting into the weeds of other hardware, that Bernard is making the free EEG development board available via SSH. And so, I don't know, I don't want to take us away from this, Jaden, but it is available. It is on the internet. And yeah. So I can, if you are interested in working on the free EG32 board, you can get in touch with me or Bernard for, the IP address and, login credentials. And he can press device buttons and attach other things to it if necessary. He's in the Netherlands, so respecting his time zone.
So.
Oh, yeah. Okay. Yeah. And this is where, so Fedora has a particular problem, but is not relevant. So I'm just going to switch to Ubuntu. I'm getting something about Muse LSL requiring an older version of Pi LSL. Does that sound right to you, John?
Yeah, that sounds familiar, but it depends on the OS.
Gotcha. Okay. Let me just check the meetup in terms of. Andre did RSVP.
All right, I'm trying to implement this right now, and I'll update you if I get it going.
Okay. Let me just check if. Good deal. Julia, if we don't get to MindX tonight, not to put you on the spot while we're recording, but love to have you come and do a presentation.
Sure, love to.
Okay.
I would really like to hear more about MindX at some point.
Great. Well, I could talk on and on about that for a very long time, so I'm happy to.
Good deal.
I'll try to get up to speed on some of the projects if that is also what mostly are you contributing to.
So, well, what I can certainly say is that we have the name Hack Night, but it is not what it is probably kind of a misnomer. It'd be great for us to make some progress on this particular project, and not that getting it running on Linux is actually really key, right? I mean, I think most Open BCI people are using Windows. Do we have a sense of that, John? Or
yeah, that's the assumption. I mean, certainly Windows and Mac, not Linux. That would be what you would expect. Right. I don't know, but yeah, it needs to work for Windows, bottom line, and then other things are an add-on after that.
Okay.
Which is kind of the opposite for me. Is I'm always Linux. I don't even program in Windows.
Same. Linux.
Absolutely. No, I hate Windows. It's just a necessary evil from some things, and my portal into the Linux, boxes that I work on in the cloud. But occasionally, when it comes to hardware, then Windows kind of becomes necessary. That's, for me, at least, that's generally when it comes in.
And certainly, I mean, one big benefit of BlueMuse is that it doesn't require this particular hardware. Like you should be able to use your laptop's Bluetooth. You're not actually trying to do anything super fancy. We're not, I mean, I saw somebody recently on, I forget which list, maybe it was EG Lab or, but they were asking about like Bluetooth 5 or, like or maybe they're asking on Slack. I forget, but it's just like, we're not doing anything, fancy, and we don't need any, high-end features. It's still kind of a mystery to me why this hardware is, the only thing that we can get working on certain platforms. But BlueMuse doesn't have that problem, right? I mean, can you can you use your laptop's Bluetooth?
Yeah, that's what BlueMuse does. Yeah,
and that's, I mean, honestly, like as far as I know Simon and Andre got into the weeds in this, but like there's also nothing like there shouldn't be anything stopping us from doing it on Linux too. So who's technically maintaining Muse LSL? Is it still Alexander?
I believe it's Alexander. I mean, depends what you mean by is maintaining.
Well, you know who did the last commit looks like is Jason.
Oh, really?
Yeah. All right. This is Koalja. Koalja's his username. So this is the BlueMuse.
Dano did a lot on it. But...
Yeah. Well, I mean, this is just the last commit. It doesn't mean he's,
Well, there was a commit 14 days ago. Yeah, okay, there's stuff going on.
Add BlueMuse stream toggling. Well, I wonder if we can get him to come back. It was great when he joined us. I wonder what progress is with his CLI recorder. He hasn't talked to you about that, Alex, has he? No. I mean, we need to get in touch with
Okay, so we've been adding basically BlueMuse compatibility in Muse LSL. That's cool.
It's not bad, right?
Yeah.
Um, all right, let me. Just trying to remember who's the. Oh yeah, right. You said you knew Chadwick Belay? No. Okay. Is it an Ottawa Sachs Lab? Sachs Lab. Oh, they've got a custom neuropipe.
Is that Rebecca Sachs?
Hmm.
No,
Yes.
she's at MIT.
Says Adam Sachs.
Adam Sachs. No, don't know those guys.
Director of Neuromodulation. Oh, BCI. I mean, good stuff. Anyway, just looking at who seems to be active maintainer of LSL. Oh, and as he also develops MagStim Python. Yeah.
Really?
Just yeah.
So the person who maintains LSL,
Yeah,
is doing TMS and
Yeah.
EEG.
yeah.
Seems like this is important information.
At the Ottawa Hospital Research Institute.
Okay.
Um,
I think they're using it for that.
I mean, I'm assuming. I mean, certainly Sachs Lab's got some cool tools for intracranial neurophysiology, deep learning. Lead DBS, which is a MATLAB toolbox for DBS like planning and simulation analysis. I don't know what Cerebrus wrapper is. It sounds good. Oh, doing some phase amplitude coupling. Anyway, yeah, they. I mean, he seems super active on LSL's. Schwartz Center's LSL GitHub, and which. Let me just go back to. Oh, there's actually a bunch of pull requests on Muse LSL.
Stephen Inks.
Okay. Well, Issy should be joining us pretty soon. let's see, what else did I put in the where did you try and catch this computational NIMH computational psychiatry meeting July 1st that got Zoom bombed?
No, I didn't try and catch that. Did you?
Yeah, you know, it was I don't know if it's pronounced Michaela or Michelle Ferrante, but you know, program director at NIMH, talking about like what opportunities and resources were available for those interested in computational psych.
No, I didn't. Is it
It got
gonna
cut.
be?
I hope they're going to redo it. Yeah, it was 2 hours with great speakers, and it was in the middle of like this professor from Virginia Tech was presenting some really cool stuff on kind of on, you know, memory consolidation, but also talking about like sleep oscillations. And anyway, it was really cool. And then, you know, just like it wasn't just a Zoom bomber, it was like a group.
Wow.
Yeah. You know, and they just, you know, they fought it for about 5 minutes and then they shut it down. And I, you know, it's funny because I did email that. I would love to hear that Virginia Tech guy speak again. See if I can get the.
The thing is, when NIH do something like have a workshop on computational psychiatry, so there's like a specific meaning of computational psychiatry. It's actually this basically the stuff along the lines of the stuff that Andrea was talking about today.
Yeah,
I mean that, you know,
it's
Ray Dolan, right? It's specifically, it's like it's principally models of learning, right? Often coming from psychometrics or even economics, but models of like learning and rational choice, kind of tailored towards experimental tasks that show either reveal aspects of disease mechanisms or show group differences in patient populations, but things like that are kind of like psychological level learning models applied in a neuroscience and psychiatry context. Like that's what the phrase means insofar as it was like claimed, you know, 20 years ago, and it's been you know, like dozens of review papers using the phrase. But when an NIH do that, you know that they're kind of saying, okay, we mean doing psychiatry with computers. And I'm just guessing that that's what the basic theme of that workshop was. Am I right?
I mean, it was definitely much broader than, you know, what we were, you know, like what you were talking about. And yeah, like when I think about, you know, the comp psychiatry, like compsych.org, you know, those meetings and the kind of the people that it brings, and, you know, as well as definitely, you know, some of Klaus Stefan's stuff and things like that. Yeah, he was definitely applying it much more broadly, and he had the program director, you know, had some discussion of, you know, like RDoC and, you know, the kinds of things that would, you know, link things, you know, link domains, and yeah, it was much broader. It definitely included, well, and it also included something about like getting things into the clinic. You know, I mean, it was very NIMH, like, yeah, and it was like how you can take the various existing resources and you know, successfully argue for computational psychiatry. And yeah, and so I dropped the link in, so this was this Sujith Vijayanan was speaking. Unfortunately, like got cut off mid. I mean, he'd barely gotten started, but he presented enough that looked good. And yeah, I'd like to see more. I'd like to see that separately. But yeah, they had a good lineup of speakers, and I'll see if they're going to do it again. So, hi, is he here?
Yep, I'm here. I'm trying to turn on my camera.
Okay, good deal. No rush.
Let me just try to sign back in and see if it works.
No problem. We're here. Yeah, I wasn't actually familiar with some of his stuff, but now talking with Kalar Kakan about their sleep, memory consolidation, TDCS, like makes me more interested in what these guys are doing at Virginia Tech too.
Yeah, they're doing similar thing, aren't they?
Yeah, it looks like it, right?
Yeah. Yeah, these models of like brain stimulation, memory modulation, memory consolidation modulation with brain stimulation during sleep is super interesting, isn't it?
Yeah, right. But when I think of computational psychiatry, I think of like Reed Montague at Virginia Tech. Not necessarily this kind of stuff.
Yeah, and Ray Dolan and Carl Friston.
Right.
They're the computational psychiatry kind of say mafia. Yeah.
If we can be of any help, Issy, just to let me know. So one thing I don't know if it's gray, I think maybe he can't hear. I should tell him to use Chrome. I don't know if it actually matters, but.
Hi, I'm back again. I don't know why the camera just isn't on. It works for everything else.
What browser are you using?
Chrome.
You are using Chrome. Okay. That is certainly what other people will recommend.
Okay.
Do you want to see if do you have so if down in the bottom left-hand corner, there's a little like monitor sign, and that's where you can share your screen. So
sure.
Do you want to see if you can share your screen and we can still hear you?
Sure.
If that's cool. So I can let me just give you a short intro, or so Izzy Goldwasser is joining us from, I think, South Bay.
Yeah, exactly.
Yeah, and hey, okay, we're seeing your laptop now.
Yeah, now you can see my screen. Yep.
So and he's the CEO of Think, which I want to say is maybe like 7 years old. More?
Yeah, actually, even more now. It's probably started almost 9 years ago.
Okay.
Almost.
Okay. And so I want to say I wasn't sure what I mean. Think I believe has had other products before, and I'm certainly really interested to hear about this. But give us some background of the company, and then tell us about Zing.
Sure. Well, since you can't see me, I'm sorry. I'll have to do it. Can you see the site there?
Yeah.
So I guess I'll just start with what's here, and then I'll work backwards. But we are a neurostimulation company, and we, as you said, we had launched previously wearables, and that was about 5 years ago. And I'll talk about the science, but it took really a journey to go from the science to the wearables, and then to a wearable patch, which is what you're seeing here, to our Zing Energy Patch. And it really is, we did this so we could really sell a consumer product, which you could find eventually everywhere, and just buy a patch. You just take it off and put it on, and when it senses your skin, it delivers a 5-minute neurostimulation to a nerve that's located right behind the ear, which is a branch called the greater auricular branch. And that's basically a branch where we had the most success to create this energizing, focused kind of drive effect that we deliver. And what it does is, and what all our neurostimulation programs do is we're basically trying to impact your autonomic nervous system. So we're looking at you know, in a gentle way, your sympathetic response or your parasympathetic response. So we can create from this location that you see here, we create the effect, and then from time.
You see, we're losing some of your audio just a bit.
That is actually even stronger. Yeah. Did somebody let me switch over here?
I don't know if it makes a difference. I'm gonna lower my quality.
Was that cutting out?
Yeah, we just lost a bit of maybe like the last 20 seconds of audio.
Okay, am I back?
Yes.
Okay. Actually, I'm gonna try to put on my other headset here. Okay, so basically what I was saying is that, let me go back to the screen,
Sure.
that in addition to the energy effect that's here behind the ear, we also developed actually quite a lot of technology to deliver basically the opposite effect through stimulating the cervical plexus, which is right behind the neck, and C3, C4 really region. That's where it begins. And again, in that area, we have a lot of more science because it's more easily measured in a laboratory environment. In other words, we can with biometrics and biochemistry, we can actually look at how we're affecting physiological stress. And so we published scientific papers about 4 or 5 years ago, one on stress reduction, one on sleep. We ran a sleep study, and it worked out really well. And we also ran a safety study. We also published that. So a lot of science that went eventually into getting to this patch here. And let me walk through, see, I can go to the science in a second. Let me see, I'll just go here. So this is a good, I don't know, again, if this is too small, let me know, but
I think it's a good
okay, good. So we began really, in neuroscience, you can use neuroanatomy and obviously the neuroscience that's known now to really target particular pathways. But what's not known is really how to signal or communicate with those nerves to create different effects or what physiological changes happen when you signal nerves. So most of the work that most people can see when it comes to putting something externally on that's a nerve stimulator or a muscle stimulator are, of course, the TENS machines you could buy for physical therapy for pain. And in those, what they do is they just block. Their whole goal is to block the signals between your peripheral nervous system and your central nervous system. And that's how they block the pain. That's how they relieve pain. What we're doing and other people are doing now is really looking at think of it more like neurosignaling, which is how do we communicate with the nerves to create certain, this is agonist or antagonist effect on the pathway. And you can think of this as, even though we have a lot of technology, we're really at the place where you could think of it as the 1500s, looking at the map of the world, where you know where the countries are, capitals, major roads, but this isn't Google Maps, right? We don't have any idea really how the central nervous system and the peripheral nervous system really work in terms of signaling and how to communicate. And so a lot of academic work is now happening to
we're losing
technologies, both invasive and non-invasive, take advantage of that.
Izzy, we've lost you again.
Still.
Yeah, no, just give us like the last 10 seconds. And maybe give it a second where I can see your I'll see your bandwidth hopefully come back. Okay.
Yeah, I can hear you. I can hear you guys pretty well.
Okay. Are other people having the audio problems or?
Yeah.
Okay. The other thing I have to check is of course it's not me, or I told my son to stop streaming his gaming from 6 to 9, and I don't know if he will listen, but anyway, please
I should do the same.
Okay, please continue. Yeah.
Okay. So I'll go back to that page, and then I'm gonna maybe to save bandwidth. I'll come back and shut off the share screen. So one thing I'll say is that actually the way we made the most progress over 2.5 years is we actually just got consumer feedback when we gave people fake waveforms, like sham waveforms, or real waveforms. And what you see here is a scale of 0 to 10. We give people a scale with different metrics, and the higher the number, the more intense the effect that they report. And so when we first started, there was a complete overlap between the sham group and the energized, let's say, the energized waveform group. And it took us about 2.5 years to create the separation that you see here, which is actually quite a lot, where you really have a real effect consistently. And that was how we quickly, we probably tried 1,000 programs over that 2.5 year period to get to what we use today. So that was a lot of trial and error, because there was really no other way, and there's still no real other way to know, to use science or diagnostic or any kind of imaging, anything to really understand how to signal and what the response of physiology is. So that's how we began, and we definitely, we spent about 4 years. Let's see if I have more. This is all that we have here. So we spent about 4 years. Go back here, getting to a product, and our product. Actually, I'll look that up just to show you. It's probably still there. Maybe some of you have seen this in the past. So let me go here. I'll show. I don't know if you could see this, but basically, we made a wearable that was actually quite an elegant system. It was a wearable that had a set of electrodes, one for energy that went on the forehead and behind the ear. The other one went on the forehead and behind the neck. It was a $200 product, and it came with an app that you paired the device to, and you were able to control the program you chose for different effects. You were able to control the intensity precisely, and all of that it was really a major effort to put that together and launch it. And we sold about 14,000 systems and got a lot of great feedback, and we were just so way ahead of our time. I think even back then, we didn't understand there were some fundamental challenges to wearables in general in terms of commercialization. But in our case, it was really severe because we had a whole new market. I mean, we were trying to start a whole new market. So from that entire effort to going to the patch has been our journey the last 3 years. And we just launched these patches very recently.
So that's awesome. I mean, in the sense that, like, yes, that's what I remember now. And so for that first wearable, was that wasn't like what we would call TDCS or TES. That was still focused on like a cranial nerve, or
yeah, that's right. We target cranial nerves on the head and neck usually, but we didn't start there. We actually started by trying to make TDCS and TACS work, but we could not get any meaningful effects that were large enough. We couldn't even reproduce the papers that we saw. I did take a tour of there's an Air Force base in, I think it's in Ohio, was it? I think in Ohio. I went and they had published a paper on using TDCS for focus for getting some of the Army soldiers to focus, and they had done a great job on the measurement side. They had done a really detailed job of testing very carefully the performance of these soldiers under this shooting game simulator, but their method for delivering the simulation was so primitive. It was wet sponges wrapped around with a band, basically a bandage, and just turning on the electricity. I mean, it was really, that's what they were doing. And
sure.
So, but other than that work, which I think is real, I think that paper is real. I would tell you, we had no success trying to deliver energy through the skull to activate any particular brain regions. And then we ran across, almost by accident, we realized that we could create better effects if we targeted cranial nerves. And that's where we focused all our efforts. That's how we built our
I'm just going to let your internet, I'm going to, from experience, going to say, let's give you 10 seconds.
Okay.
I'm showing it still as gray. I just don't want to miss anything, but.
Yeah, you're right. I have a poor connection. I don't even know why. I think my entire family must be watching different things.
That's, yeah, I've got to do some router filtering. So on the off chance that this is your audio is back, what about certainly right now, I think bioelectronic medicine is much more is much more popular, much more mainstream, and so I guess one question is, why aren't you doing vagus nerve?
Well, vagus nerve stimulation, I think the companies that do it, at least the ones that do it the most successfully, are doing invasive implants for bioelectronic medicine.
Okay.
And yes,
so
as far as I know.
It's really like you wanted to stay non-invasive. I mean,
Give me 1 second. I'm going to try to make my bandwidth.
Sure. Here, what I can do is I can share my screen with the let me just.
Sorry, can you guys hear me?
Yep.
Okay.
And I put onto my screen the think website, and
yep.
And I can certainly, I know I was looking at some of these So these were, oh, this is Bixen.
Yeah.
Okay. So, yeah, I mean, so I think last fall, last fall neuromodulation Napa, I did the, their workshop, and we were literally attaching sponges to our heads.
Yeah, right.
Yeah, I mean, so like that's obviously not something that you can sell. But that is how TES work started. And so what's this? This is tolerability. So this is definitely focused on TES because it's strange.
This is everything we do is TES, right? And we're targeting cranial nerves. And bioelectronics, bioelectronic medicine is really growing. There's some big investments, and they're all really spending their time initially doing two things: mapping out the nervous system at the level of to signal it, and the other major thing they're doing is really looking at. Sorry, can you guys hear me?
Yeah. No. My
Okay.
apologies. I was on the website. I opened up the article, but I wasn't sharing that particular tab, so people didn't see the Bixen paper. Anyway, please keep going.
So I was just saying that aside from looking at the nervous system signaling, which is very important, they also are working on miniaturization, because a number of these companies are looking at one. If they're not going to do implants surgically, they're going to look at subcutaneous implants or other ways to do this. Our effort, it really was always about, we always had a passion for consumer products, and really from experience, we've learned that we need to make it really incredibly convenient, easy, and that's where the entire patch format came out.
Gotcha.
Yeah, and it's neat. So, what's really neat about it is when you with the patches, you put it on and it comes alive on you. It's like nothing else you've tried like that in that sense. You put it on, it just basically goes on and delivers this, and then it comes off, and you can feel you can really feel it when it's running.
So here's let me share another article here. So this is Jamie Tyler's first author, and is now so this looks like it is focused on the nerve response, or the autonomic response. Is that correct?
It is, yes, that's right. This one it's basically lowering physiological stress levels. And this was our main paper on stress reduction, and so we had a combination of biometric measurements, biochemical measurements, the consumer or subject reported outcome measurements. We had thermographic imaging, and we had a whole host of other things. So yeah.
So yeah, that's interesting. So this is do you know like what cameras you had to use for that?
Thermographic imaging?
Yeah, is that where did they?
Were pretty, yeah, they were pretty. I mean, they weren't expensive from the point of view of lab equipment, but they're probably like $7,000 cameras. And if you go down and you look at some of the figures, you'll see some of those images. They're very neat. But the reason that works is because when you trigger the parasympathetic response, you have vasodilation. Basically you have dilation of the blood vessels at the skin, and that actually results in a temperature rise. So it's a little bit counterintuitive, because that means when you're relaxing, that means when you're in your parasympathetic mode, you actually get warmer. Most people think when you're upset and really mad and you're really your adrenaline's flowing, that you're actually somehow hot. But it actually turns out that it's your parasympathetic response that actually warms up your face and your extremities and so on. So if you walk through, you'll see some of the figures, you'll see that.
Sure. Sorry, I was just getting at, this thermoregulation of skin temperature, and then obviously you're also doing like galvanic skin response and very cool. Oh,
That's
there you
right.
go.
Yep.
Okay. Nice. Now this was maybe like 5 years ago. You think any chance these cameras are cheaper now?
Maybe, yeah. You got to look them up.
But
they probably are. I'm sure they are. You probably buy a used one, actually.
I mean, like this is, I assume, heart rate. I mean, so you're getting like ECG plus galvanic skin response.
Yes.
And interesting. Oh, okay.
And so we tried a lot of things. Let me tell you, we tried probably every biometric combination. We tried all combinations of things. Biometrics are tough because even within one person, even if I did it with you with laboratory grade equipment, just the fact that if you stand up and we're sitting down, you will trigger many of the biometric signals. Just getting consistent baselines and seeing real changes is I felt like we were doing lie detector polygraph testing. It was I can see why it's not really reliable at all. But we did EEG, laboratory grade EEG with like 96 different electrodes as well.
Is that in this paper, or is that a different? Sorry, I'll keep going here. Oh, cool.
Yeah, that's the thermography. Yeah. So that's where you could see the differences over time in people, and you can measure that and get.
So they're
statistically significant difference between the fake and real.
Sure. So they're looking at like maybe something like IAPS images to, so I saw something about fear conditioning, or what's the stress here?
Sorry, so you cut out for most of that. I just heard the last part. The stress here on the
yes, like how were you trying to stress people out? Like showing them disturbing images, or
No, actually, I think in some of these cases we actually literally shocked our finger.
Okay.
And
old school.
And that stressed the heck out of them. Yeah.
Sure.
You know what's funny? What's funny is it's actually not the actual shock, because it's actually quite mild. It's the anticipation of the next shock that stresses you out.
Sure.
That's what happens.
And so salivary alpha amylase and cortisol. Did you get some effects there?
Yeah. So the alpha amylase was actually our best result. That's a basic surrogate for a stress marker, and it really is real time. It changes, and I think with cortisol it was more difficult, but that's because also cortisol has a circadian rhythm to its concentration, so it makes it very hard to, you'd have to run the experiments at the same time of the day for everybody, and even that's not really the right way of doing it. So it makes it very hard to do cohorts and lots of people and pool the results. But the salivary alpha amylase was really actually quite good.
Yeah, that's so super interesting. Oh, okay, yeah, okay. Here's the shocks. I see.
Yeah.
Okay.
So the neat thing is that we're selling like these patches. I mean, all this technology, and in the end, you get a patch that you can buy that basically used 2 times. They cost like $7, and so it's kind of neat because anybody can afford it, anybody can try it, and I do recommend people just especially if you're interested in neuroscience, you might as well just give this a shot and try it out. It's fun, and if you want to use it actually for energy, you want to use it then at the same time every day, just for 3 or 4 days, just so you can start to see the impact.
And just to show people here, the last paper, this is the sleep one, I believe here. And so would you, so when you talk about Zing energy, is this is because this is focused on a different nerve, or would you say?
Yeah. See, the stress reduction and sleep can be it's more easily quantified and measured. Not that it's easy, but there's ways to do that. With energy is really hard. I got to tell you, it's really tough to try to measure that in an objective way, and then be able to publish. So we could never take our data, and it was just not something you could publish in a scientific journal. But we generated quite a bit of data on energy. It's just we know we have a real effect. It's just not what you publish scientifically.
I mean, this really does. It looks interesting. So can I take? I mean, what if I put a Zing in the same spot as the original? I mean, can you use these? Can I use these off label?
Yeah. I mean, I can't say for sure no, but I'll tell you they were specifically designed for only that spot.
Sure.
So it shouldn't do anything. If you put it somewhere else, it really shouldn't do much. Gotcha. But you're welcome to try. We get some people trying some crazy places.
So yeah, I mean, it is a good question. I mean, so what have you tried to measure in terms of energy improvement? Exercise.
We did do some. Yeah, we did some reflex focus testing early on. Again, we never really could get convinced that those things mattered that much. If you're slightly faster reaction speed or able to show a slight improvement on focus in a particular test, we never could get ourselves comfortable that really translated to a consumer effect that mattered. But those are important things to do. And what's funny is that for caffeine, it's hard to find those as well. It's not an easy thing to do, even for the most popular drug in the world, really. And even with caffeine, you can do a little cheating because you can have people abstain, which from coffee, and then you can give them a lot of caffeine, and then you get the maximum effect. And even there, you can measure some improvements, but not incredibly. A lot of it is perception. A lot of it is there's a real effect. Caffeine is obviously working, but it doesn't give you great abilities. It's just you do just feel more energetic. You feel like you want to go do something.
Yeah, I mean, I've certainly appreciated some of the studies. I don't think there's been enough, but some of the studies that have looked at sort of related to this. I know Bay Area microdosing and
sure,
in particular, not so much the microdosing, but people using off-label medications to maintain focus and energy, and some good studies showing like just the fact that you feel like you're doing better doesn't mean, if you're not collecting measurements, if you don't have real metrics, like your verbal self-report is not what you should be trusting. And in particular, when people were trying to do this and then perform some complex task. So, like it sounds kind of funny, but basically I think they were giving chess players amphetamines and then seeing if they could, play better and faster. Right. And and it was, it was of course negative results, right? It was a somewhat smarter study than what I'm describing, but it just shows like having those metrics is super important. And with the, you said auditory nerve,
for which effect? For the auricular, yeah, greater auricular, yeah.
So do you think that some of these like salivary measures, cortisol things would also be shown significant with this?
I can't. We tried. I don't think we saw anything
Okay.
like that. But yeah, I think that's the toughest thing about being in the energy market, is that it really is difficult to quantify and scientifically publish something. I mean, we can quantify it in terms of the feedback. That's how we develop the effects. But in terms of something objectively measured, very hard. So.
Yeah.
I think the other thing that's important is, on the plus side, there's a built-in defense mechanism. This is incredibly safe because you have it's localized, targeted, and then your skin acts as a barrier as well. So before you would hurt anything inside your body, you would just be it would just be really painful on your skin. So that's a good thing. The bad thing about that is that with chemicals, with substances, you can overdose and have no doubt that it has an effect on you, right? Yeah. So if you doubt that coffee has an effect, you can have 4 cups of coffee and then it has an effect. Yeah. And if you doubt that 1 beer does anything, right, because it's just too mild on you, well, you can have 5 or 6 and then there's no doubt anymore. And that is what we cannot do. We cannot just crank it up and overdose someone. It just doesn't work that way. That to me is the missing piece. That if we could find out the neurosignaling, at a greater depth and do more specific work there, we meaning the community at large, then if we can find a way to really, maximize the effect in terms of dosing, that will be what really convinces people that this is for real. All these things are really have effects.
Sure. So yeah, I think it's still a question if we can track this with EEG. Not necessarily energy, but some of the measures that have been put forward is focus and other things. I think it's interesting because, of course, the difficulty in trying to, in their own attempts to have metrics that show that works. Some of them are just these circular logic kind of paradigms, or they show that people when working have more of this EEG, and not
EEG. EEG is a great tool, and you have to be very careful with it. And the reason is that the best analogy about EEG is thinking about it like it's like you're standing outside a football stadium while the game's going on, and you're trying to figure out what's happening inside in the game, right? And yeah, when there's a touchdown, when there's a turnover, when certain major things happen, you can figure that out by when the crowd tries to in unison boos or cheers, etc. And so that's what EEG is like. And as much as people want to make it into a very specific tool and say that they can train, they can really look at the waveforms in a much more specific way, I haven't seen that. And more importantly, the biggest signals you get when people are trying to measure focus and relaxation is actually from muscles on the head and the chain and just flexing and relaxing those muscles. So when you buy these, especially consumer grade, stuff that you put on, and they're trying to tell you if you're focused or not focused, meditating or not meditating. A lot of times, what's happening is they're learning. The thing is training to figure out the way you behave, and the biggest signals that you give it are how you kind of tense up when you're trying to focus, and you relax when you're trying to relax. I mean, you relax your muscles, and so I think that I think cleaning all that out and making it work and doing that with only a few electrodes, I'm just not convinced yet. Which is why all these little gadgets and tools and products that come out, they're kind of 70% accurate, and they have like a 1 or 2 second delay, right? That's why when you had some really cool, you guys remember those? I don't know if you still have, like Emotive had some real videos where you could control things floating with your mind, by just.
Well, I think most of the companies have at least something like that. Yeah.
Exactly. Yeah. So when you play those games, you'll realize right away it's kind of a 70% good, and there's like a 2 second delay, and so the whole thing, it doesn't quite work the way you imagine. When you first hear about it.
Sure. Well, obviously, we're hoping to change that about EEG, or certainly, yeah. But what you said is certainly a big problem, where it's like if movement is confounded with the kind of the thing that you're looking for, in the sense that like focus is less movement, right? You're not really sure what you're picking up, and that's we have that problem in neuroimaging. In the MRI, you can find certain things are correlated with increased movement or increased, even like fidgeting, and it actually, it creates a bit of a confound in the signals that you're actually interested in, especially if you want to say something physiological as opposed to just phenomenological, but anyway, well, I want to give other people a chance. Like, anybody else have questions for Issy?
So I was just looking at the website, and I was wondering, I guess, like, is there any recommendation of starting with the lower strength, or because I drink like a lot of caffeine, and so I'm interested in something that'll give me that boost with that, and so I'm kind of inclined to just go straight for the extra strength. Is there any reason I shouldn't?
No, you can definitely go straight. I think it's a matter of whether you mind, like it's just more intense sensations on your skin. So it's just a matter, it's more about whether you want a smoother experience to start with and get used to it and then go to the more intense one, or whether you don't mind and it's, you're kind of one of these people that just enjoys a little bit of intensity, even a little bit of pain. It's not a problem for you. It's sort of like, yeah, bring it on. Then go ahead, go to the extra strength right away.
Cool. I think I'll go for that then.
Great.
Hey, this is Alex, and we work with esports athletes doing performance tasks over periods of time. And one of the things, we use both eye tracking and EEG to try to combine those metrics. I would say that we've started to see signs of onset of fatigue in people if they do tasks long enough. And I can think of a very interesting experiment where, we have people do something for a chunk of time, we give them a regular break, and look at that as the control group, and then another set of people where, you have them wear the patch for a few minutes and you see how much of a change in like that fatigue related buildup, performance loss, biomarkers do you see. Certainly not anything like fancy or official, but have you explored the area of like quantifying the performance gain of this versus like just taking a standard break?
I would love to do that experiment. Esports is an area we think this could be really a great fit. In fact, we actually, if it weren't for the COVID environment, we would have already done that. Not the testing you're saying, but we would have already had. We had basically we had already supplied patches to one of the esports teams. I think it's called Cloud9.
Yes, very well known. Yep.
Yeah, so Cloud9 was going to, one of their teams was going to use our patches to see, because I think the issue there is that the people there were really concerned that the esport athletes are just overly reliant on caffeine and wanted to
Yes,
just
the major concern.
just have them back off. And the issue with that is, with the caffeine, is that you get into this crazy cycle where sleeping becomes an issue, and then it just cascades into a problem where you have to have a lot of caffeine during the day, and then you have to start taking some melatonin or other supplements at night, and get into this crazy cycle that you can't function without the caffeine. And so that was, I think, the major issue. And with baseball players too, we also had interest, because baseball players versus basketball or football, they have so much travel, they have so much time really that they spend, that they also use quite a bit of caffeine. Since they're not allowed to do anything else, they're using quite a lot of caffeine. But really, the clubs don't want them to, drink energy drinks all the time, or have too much coffee. So I would love to, if you want to run that experiment, I'd love to do that with you guys, and we can maybe work on that. Yeah, you can just write me at just write me an email at isy@think.com, and it's isy@think.com, and
Sounds great.
THYNC.
Great, thanks.
Yeah, that's awesome.
And by the way, I agree that fatigue is something you can measure, and that is a great application. That's a great way of using biometrics, and that would be a great test to run. And yeah, the beautiful thing about this is that it doesn't, even if it works really well, but even if it just gives you a small boost of energy and gets you through the next hour or two of what you want to do, then when you're done with that, then you have no downside. There are no downsides that you would have had if you had taken something with caffeine. And so you really start to see the benefits build day over day for people. And I wouldn't suggest people quit caffeine cold turkey, because then you'll go through withdrawal. But I think you could certainly cut back quite a bit.
Yeah, absolutely.
So is there no chance that we'll see the cranial nerve tech come back, and
the patch? You mean a stress patch or a sleep patch? Oh, well, I'd love to. I'd love to. Yeah.
So
you mean the wearable or the patch version?
Either way, as long as you can get some of these, like these cortisol effects and these, oh
yeah, I'd love to do that. That requires the broader investment. That's all it is.
And so can you say anything about that? Like, I don't know what happened to that product.
Oh no! It's just that we had to develop one thing first for the patch, and we developed the energy patch. But the beautiful thing is, if we have broader investment base, then we could absolutely launch a stress reduction patch, a sleep patch. That would take us probably 9 months, 6 to 9 months to do.
And would it? In broad strokes, can you say like what it would need? Does it need more capacity because that's a deeper and or longer stimulation, or
we know no, it's not. There's no breakthrough or innovation needed. We have everything we need to make it. Yeah.
Gotcha.
Yeah, everything we learned from the energy patch, we would just use for that patch, and we already know the waveforms we would deliver in the location. So just a matter of, then going through the process of development to make sure that you have a nice product that works.
And you don't think going a medical device route is something in your future?
Well, the answer is, again, that takes a bigger investment base, and then you have to pick an indication. In our case, we could go for something that was more, general anxiety, disorder, some type of a specific anxiety disorder. And it's an area where no one's doing a lot of work in the pharma world because there are already too many generic drugs available, and they're quite good for people who have real serious problems with anxiety, but they're obviously not. They're overused, they're overprescribed. Most people should not be on Xanax or any kind of other benzodiazepine. I mean, it shouldn't. That's not what they should be doing. But so I think it has a place there, and that would probably be a place. But again, it's really investment oriented, and we're still, even after all this time, we're still way ahead of the market with these kind of products.
I mean, I think, I mean, given, I mean, this is my amateur take, but given the focus and investment on invasive things like vagus nerve stimulator, I would think that people would say, like, wait, you mean I can do something that doesn't require surgery? and that, like, I mean, I still, couldn't you still be selling that wearable? Was there a problem with that particular factor?
Well, I think to have the thing is to have the operational team, production team, and marketing effort to really sell that wearable. It just required a certain level of investment that we had for a while, but we couldn't sustain. So, and I think that's the real issue. You have to have a big enough market. You have to have a channel of distribution to be able to then justify the investment. That's why we went to a patch, because a patch solved major problems that were fundamental to wearables in general, wearable devices, and really got to a pure consumer product which has distribution, which has a lot of the fundamental issues solved already, and that's why we went to a patch. And then also we knew that for consumers, as much as we love, let's say this group loves maybe a really cool device, the fact is, in the end, we're all human, and if we're looking at something that you do all the time, you just don't want to recharge something, carry something around, have something you have to pair and use. You just want to rip open something, put it on, and have it work. It's just kind of like boom.
I see.
Yeah,
I see.
And I tell you that after having designed an incredibly sophisticated, elegant wearable system. That had everything you want in a wearable system for this type of technology. But it just isn't, even when it's really cool, but it's just not what people need for everyday life. You need something much simpler. Now, if we could deliver like a digital drug, like say like the effect was more like, getting high or doing something that is super intense, but now you're doing it digitally, that's different. People would buy a device for that. But in general, I don't see it unless it's an over the top effect. I don't see it working with the devices.
What about, I mean, you've got, Jamie's got a paper doing sleep, looking at sleep quality. I mean, could you wear it at night? And
you don't want to wear it. You could, but when
I mean, I'm talking about the cranial. Yeah.
When you wear it behind the neck, the cranial nerves are behind the neck. The issue is when you lay back and you lay back on it, your neck, the shape and what it does, it's just not ideal. And you don't want to have something that's stuck on you all night. So I think the way you do this is you actually want to do this about, half hour to hour before you go to bed. You do this as a way to come down from the day, really it's kind of your meditation. It's kind of your meditation now, and that's why it works so nicely. It's part of your bedroom routine, like, just a bathroom, evening routine. You just do this, and then it just calms you down, especially for people who have very active minds and really have a hard time just turning their mind off at night. I think this type of technology would be great.
Okay. Well, I would still love to have it available for researchers. I mean,
sure.
For people to do these studies,
Yes.
and to flesh out these effects. And yeah, but I mean, hopefully we can also, if need be, we can also look at the papers and figure out what stimulation we should be doing. But yeah, super interesting. And
no, thank you, and thank you for having me on tonight, and I appreciate it. And yeah,
definitely. Well, Alex will be in touch, and yeah. If you ever see, if you've got something new that you want to talk about, please come back. And yeah, I know we're hoping this month to get somebody working on vagus nerve stimulation in a clinic. I think UT Dallas. Anyway, but yeah, really appreciate your time. And obviously hang out if you want.
Thank you. I'm actually have to go because of my kids, but thank you, Morgan. I appreciate it.
Cheers. Take care.
Thank you. Have a good night, everybody. Bye.
Good night. Thank you.
Yeah, I hadn't actually looked at all of these papers. I mean, I knew that Jamie had done some of the. I mean, I know he was involved. Certainly Maren Bixen is someone who knows DDCS. I didn't see what was. And so I highly recommend neuromodulation as a conference for those who are interested in this. So I know Maren Bixen is one of the organizers, and there's a lot of work still to be done in fleshing out the nonlinear responses of electrical stimulation. Certainly all this kind of nerve stimulation versus brain stimulation.
Is there a neuromodulation conferences soon?
Say again, Nadim?
Is there a neuromodulation conferences soon?
Yeah, so they actually, because of COVID, Neuromodulation NYC was online, and so I believe everything's available on YouTube. Again, really recommend it. Lots of people from NINDS, and I want to say that HEAL is run out of NINDS, and people, yeah. Yeah, well, and of course, it's also where you can try out more SimNibs computational modeling. But yeah, so it was the West Coast. They come to West Coast and East Coast fall and spring, and so I assume they're planning to do something in October, but I'm sure it'll be online. And yeah, great stuff. Oh yeah, roast. So for all the neuroimaging and modelers, and yeah, lots of pain, obviously pain modulation. Yeah, so we'll hopefully, I don't know about next, maybe next week. I'm not familiar with Mindex, but that would be great. We've still got some time to talk more about.
I know a little bit about Mindex.
Oh, okay.
Yeah, they're all I know because I actually applied for a couple jobs for them through NeurotechX. They do BCI AR applications for spatial computing. So I don't know exactly what their applications are yet. I actually messaged Julia on Slack just recently to pick her brain more about it.
Okay.
But yeah, it looks pretty interesting.
Let's get her back to talk about it.
Yeah.
And certainly I was hoping to. So I don't know if Alex Peak has joined us this week, but so Ryan was working on some stuff today. Won't be able to join us, but I know Ryan's a part of the Project North Star community, which is an open source AR headset, and I was hoping, kind of hoping that he or someone from that group will come and talk about that, and certainly like adding EEG to that would seem like would be potentially a cool project for someone. It's the kind of set where you can 3D print a lot of your own parts for it. And if you are on the NeurotechX Discord, I think in general, Ryan posted a link to the Project North Star Discord.
What's the, is it just NeurotechX, the server name? Or do I have to get an invite?
Discord channel? I don't know. Does anybody know Discord better than me?
I believe an invite link is usually the way it works. It's a lot like Slack, where if you just click the invite link, then you can, auto join or whatever. I don't think it's difficult to find, but I don't have it handy.
So let me I'll invite you, obviously, Jaden.
Okay, cool, perfect. Because I'm on Discord a lot.
I just need to. Okay. Yeah. So, but any other news or topics that people would like to cover in this last 15, 20 minutes? Let me just send. So, Jaden, tell me if that works for you. Tomorrow is going to be, we'll have our weekly diversity meeting. For those who are interested in joining us between 11 a.m., 1 p.m. Pacific time. And cool.
What was discussed last time in that, Morgan?
So we tried to get a bit more practical. I mean, obviously, first meeting there was a lot of setups and introductions, and but we've got their meeting notes available. Abby's been great at posting those, and so one of the things that we wanted to do was try and talk more about this to other chapters. And so, Abby's, I think you might have seen that Brian mentioned this for all the NeurotechX chapters kind of like announcing it on X Leads. So one of the things that I've been doing is just checking in with the Spanish translation of learn.neurotech.edu, because Maria Virginia and Diego had been working on that, but they were both also finishing their PhDs. So anyway, I checked in with them, and they, are taking a well-deserved break from graduation, but are, Mavi was in particular was like, yes, this is, good that that we get back to that. So mainly because they'd already done a lot of work, so it was pretty close. So that was some of our kind of like, what translations could we work on to definitely improve that sense of accessibility, and then expanding our tutorials as a baseline education program would help newcomers, and yeah, that kind of gets at some of the Neurotech edu 2.0, but I think it's more, even things like I don't even think like some of the tutorial scripts were available from BCI 101. Like, they just weren't linked off the website. And it'd be great to have more, more baseline newcomer projects. Yeah, and certainly we're still looking for ways in which we can expand the highlighting of neurotech in less academic contexts. So those were, and we're really hoping to also get more, get a better sense of the current community and the diversity in the community. Even though we talked about the fact that it was also a bit of an exercise in that you're only going to get response, like if you're only doing online Slack polls, like you're not really getting the whole community. And so yeah, anyway, I mean, eliminating language barriers and a lot of that. Yeah, I mean, some of this also gets to, like, how are we really going to do any outreach post, until like there's a vaccine and things go back to some sort of normal in in-person meetings, in the sense that, like, how can we share hardware, or how can we have a physical location for people to experience the hardware, when it's so tough to meet in person. But when we are capable of doing, certainly here in San Francisco, it's great to hear, a real interest from Noisebridge in terms of having us do more stuff there in their new space, which is, for those who haven't heard, for those in San Francisco, Noisebridge is moving to 272 Cap, which is like a block away from where they were in the mission. But in having the new space, and because of COVID, not having to kind of like have everybody move into it straight away, they're thinking a lot about the space planning, and and seem to be genuinely interested in having some NeurotechX presence, or some neurohacking there. And it is certainly a way in which we could, make more equipment available to others, you know, even if it's not equipment that we can kind of like lend. And yeah, so please, if you can join us tomorrow between 11 and 1, we can talk more about, we can brainstorm more about some of these issues, and hopefully we will also be able to, you know, so I'm hoping that there will be a chapter town hall so that we can talk about the Discord channel, because I really, you know, again, like, you know, these messages that I pulled out from Simon, you know, from March, with some, you know, some code issues. You know, if that had been in Slack, those messages would have been lost, right? And now that just happened to be in like a Google Hangout, but you know, Discord is pretty, you know, I have a hard time understanding how it's any different than Slack, except having additional features. You know, I mean, you can add voice chats and things like that to Slack. You know, certainly it integrates with Jitsi, but you know, I believe all these platforms have, you know, kind of like apps you can install and things like that, and just not losing messages is so key. So I know that you know, BrainHack finally shut off their Slack, and they're now in the process of talking about upgrading their Mattermost. You know, which again, like I feel like Discord is giving us everything that Mattermost has, but yeah, if anybody knows more about that, I'm certainly interested to hear about that when we then go talk with Yannick and others, because that just is so important. And yeah, so next week, in addition to Neuromatch Academy starting, which, you know, again, for those who can follow it, it should be, you know, the Python pre-train or pre-conference. Let me see. Does anybody have a link for that? I haven't been following, you know, what they've. Okay. Yeah. So they're also, I mean, just for those who aren't familiar with it, NeuroStars is another, you know, I don't want to say it's designed as a, you know, it's not a Mattermost replacement, but NeuroStars is a good place for, you know, these kinds of neuro related questions. I mean,
it's more like a Stack Overflow.
Yeah. But certainly the you know, it was kind of designed with the idea that like these messages won't go away, and like, and they'll be searchable, and I know that they've kind of partnered, or, you know, they've I think Neuromatch Academy is using them. I know CNS is using it. Oh, is GSOC as well? Anyway, I'm just going to put that in here too. But there's just a link to the Python pre-course for Neuromatch Academy. And and you can see the Neuromatch Academies listed off of Neurostars, as well as Brainweb, July 15th. So that is that Wednesday? Sorry. Yeah. So Wednesday next week, Brainweb will be meeting on their Jitsi, which is literally their web presence, other than I think their Twitter account. Anyway, I definitely recommend that too for next week. Neuroscience collaboration in the time of Corona. And any more items to bring up before we wrap up for today? Hey, Josh, did you want to talk any about some of the things you're working on? No. There is no pressure. We've got one more day of the Kremble summer school, which is awesome, and yeah, I'm looking forward to rewatching some of those crowdcasts. I posted in the Slack the Imperial Neurotechnology 2020, which is another great set of lectures, crowdcast lectures, and let me just see if I can find the exoskeleton stuff that no. No. Well, that's all I've got for this week. Yeah, I'm not finding that that exoskeleton stuff. I think actually I know where that is. It's in Firefox. Let me see if I can. Did I? Here's the Neurotechnology 2020. And I'm not finding that. Mm. Yeah. I will find later if I was hoping, Jaden, that I think you had your friend Dylan join a while ago, and like he was working on exoskeleton stuff.
So it's he's not. Well, I guess he's going to start working on it. He just graduated from my university, and so he's going to be starting at the lab at University of Michigan. Let me see if I can find the link for the lab he's going to be working at.
Yeah, please. You know, I will.
There you go. I just shared the link. It's called the Chestic Lab.
Cool. Oh, nice.
Yeah.
Okay, so they're doing real recordings. I mean, it's not just focused on the exoskeleton. This is.
Yeah, they're doing the real cortical BMI recordings.
Yeah, you know. Oh, Michigan. Okay, I have. I think she spoke at maybe one of the brains meetings. Man, you know, like meetings focused on intracranial stuff.
Yeah.
Yeah. Okay. Oh, so he just graduated from Las Vegas, but he's going to Michigan?
Yeah. So I'm working with him on a project. I'll share the link to it. It's have you heard of the ANA Avatar X Prize project? It's like the movie Avatar.
I think I've heard of the X Prize.
Yeah, so the idea is to create a robotic avatar that you can send across the world and then experience everything that it's experiencing in real time in a virtual setting. And so I'm working with them to like add a BCI element to them. I'll share the link to the project because and so although he's leaving to go work at University of Michigan, he's going to be continuing to work on this project with us as well.
Cool.
There we go, virtual Hubo.
That's awesome.
Yeah, so we're working with the team that, well, the lab that he's a part of here came in second place or seventh place, I think, in the DARPA Robotics Challenge like 6 years ago or something.
Yeah. Huh. Wow. I mean, this is pretty cool. Yeah. Okay. Nice. Yeah. Gestic Lab is hardcore.
Yeah, their stuff's really cool. I'm looking at it if I don't get some long-term job, looking at just trying to get something in the meantime and then applying to do my PhD there with them.
Yeah. Okay. Well, it's midnight pumpkin time on the East Coast. So I want to thank Alex as always for being our videographer and editor. I see the stuff go up on YouTube very quickly, and that's awesome. I know. Yeah. So I actually got some questions about that from people who said that they couldn't join because they didn't get a message about the password, but I don't. It hasn't changed. So much appreciated. And as always, if you're interested in presenting something, please get in touch. And if you want to get added to the agenda so that people can know about it and they can tune in, yeah, please let me know. And anybody got any final words? If not, I'm gonna go meet some ice cream promises.
And have a good night, Morgan.
Okay. Take care, everybody. And
Good luck.